Welcome! Today's video is going to be about Charles' law. Charles' law, if you write it out, is temperature 1 times volume 2 equals temperature 2 times volume 1. Now Boyle's law is pressure 1 times volume 1 equals pressure 2 times volume 2. Charles' law, we're going to switch them. It's the starting temperature with the final volume. So, don't make that mistake. Now, that one is flipped because the original form of Charles' law is a fraction. But I know you guys don't like division, so I turned it into multiplication for you. You're welcome. Now, filling this out, when blank is held constant, the volume and temperature of a gas are blank proportional. Now, in this formula, we have T and V, temperature and volume. The one that's missing is pressure. So in Charles' law, we're assuming that pressure is remaining the same. So held constant means the same. The volume and temperature of a gas are blank proportional. Now in Charles' law, they're inversely proportional. As one goes up, the other goes down. But in Charles' law, an increase in temperature equals an increase in volume, or a decrease in temperature is a decrease in volume. Now, mathematically, Charles' law is stated V over T equals, then it's going to be V over T. Or V1 over T1 equals V2 over T2. That's easy. 8. The blank temperature scale must be used in all gas law problems. Now, first off, this is bad because the answer is Kelvin, but Kelvin is not actually a scale. That's why it doesn't use degree. It's just K. So, anytime we're solving any sort of gas problem with temperature, we must use Kelvin. Now, sometimes I'll give it to you in Celsius. To turn Celsius into Kelvin, you're going to add 273. So 0 degrees Celsius would be equal to 0 plus 273, which is 273 Kelvin. Now, Celsius has a degree symbol. Kelvin does not, because it's not a scale. If you put it there, I'm not going to take points off, but, if you want to be right, don't put degrees. So it's just Celsius plus 273 equals Kelvin. Pretty easy. So let's work through two problems, and number 11 will be for you guys. In number 11, be careful, because I give you the temperature in Celsius, but the final temperature also needs to be Celsius. So I'm going to leave that to you to figure out how to do it. So, number 9. At 189 Kelvin, a sample of gas has a volume of 32.0 cubic centimeters. What volume does the gas occupy at 242 Kelvin? So, just like always, we're going to fill in what we know. Temperature 1, volume 1, temperature 2, volume 2. Now, our temperature 1, that's the one we're starting at, 189 Kelvin. It's already in Kelvin, so we don't need to make any changes. And the volume that matches that is 32.0 cubic centimeters. Now it says what volume. That's going to be the one we don't know. So the volume is unknown. Does the gas occupy at 242 Kelvin? Now, looking at this relationship, if temperature increases, then volume increases. Here, temperature 1 is 189 Kelvin, temperature 2 is 242 Kelvin. That looks like an increase to me. So our hypothesis, V1 compared to V2, V2 should probably also increase. So we're going to keep this as our hypothesis and see what we get. So go back to our formula, which is right here. T1 V2 equals T2 V2, V1, my bad. T T1 V2 equals T2 V1. Now we come back over and fill in what we know. T1 is 189. V2 is unknown. T2, 242, and V1 is 32.0. Now again, you guys can't see it, but let's pull out my calculator. So we do 242 times 32.0 gives us 189x is 7,744. But we want to know what the volume is all on its own, so we divide by 189. And that gives me 40.97, and its volume, so our unit is centimeters cubed. But for you guys, I want you to round to the nearest tenth, so 1 decimal point. So this 7 is going to round this 9 up, but 9 rounded up is going to round this 0 up. So really the answer I want is 41.0 centimeters cubed. Now, our hypothesis was that volume would increase. If we solved 41.0 centimeters cubed as our volume, is that an increase from 32 centimeters cubed? I believe so. So if I clean this up a little bit, there's the problem in its entirety. There we go. Now let's solve number 10. The gas in a balloon occupies 2.25 liters at 298 Kelvin. At what temperature will the balloon expand to 350 liters? Now, I didn't tell you which one is a volume and which one's a temperature, but using your units, you should be able to figure it out. Liter, that's going to be a unit of volume. It's how much space something takes up. Whereas K is Kelvin, which is, ta-da, temperature. So, let's fill in our T's and V's. T1, V1, T2, V2. My first temperature is 298 Kelvin. My first volume is 2.25 liters. At what temperature? So temperature is now my unknown. And my second volume is 3.50 liters. Now, we know that they are a direct relationship. If one goes up, the other goes up. If one goes down, the other goes down. So my volume went from 2.25 to 3.5. That is an increase. So my hypothesis is that T2 should be an increase from T1. Now for the best part, let's do the math. 298. Oh, whoops, I jumped ahead of myself. I gotta rewrite my formula. T1 V2 equals T2 V1. So T1 is 298. V2 is 3.50. T2 is unknown times V1, which is 2.25. So we multiply 298 times 3.50 is 1,043 equals 2.25x. We're going to divide both sides by 2.25 to get just regular x. So divided by 2.25 gives me 463.6. Now, that looks like a number, but I want a temperature, so I need a unit on there. 463.6 Kelvin. That's a temperature. Now, our hypothesis was that because volume went up, that temperature should have gone up. 298 was our start, 463 was our end. That sounds like an increase to me. That's a reasonable answer. We're good. Now, you're going to solve number 11. Remember those warnings I gave you? You're starting off in Celsius and you need to end up in Celsius. You're going to rework this formula to figure out how to convert those. When you're done, go to Google Classroom and post your answer in the form.